So today we are going to demonstrate a program for finding 2's complement of a 16-bit number. We use keil Vision 5 for the programming part. The program begins by including the necessary C header files, reg551.h and kjc serial.h, followed by the declaration of main. We use four variables: lower byte, higher byte, LB is for storing the lower byte, and HP is for storing the higher byte, C is for carry, and A is for storing the value of 1 which is needed for the 2's complement. We set T mode to 0H20, timer to mode 2, and TH1 to 0H15, 9600 baud rate, and SCON is set to 0H50, which is SCON mode 1, 8-bit UART, keeping the microcontroller receive enable. And we set tier 1 equal to 1 and enters the while loop as while true. We assign C equal to 0, C is carry, carry is assigned as 0. And since the word length of the 8051 is 8-bit, we have to store the 16-bit in two variables. We take the variables as higher byte and lower byte. So we pass on the message to the user to enter the higher byte, and the first two characters entered by the user is considered as higher byte and is stored in HP using the read byte PC. Similarly, the second two characters entered by the user is stored in lower byte using the read byte to PC. We print the input that we got, that is byte to PC HP and byte to PC LB. So we get this in a single line. And here we are using HP equal to negation of HP and LB equal to negation of LB. So this is a function for finding the complement. Say if HP is given taken from the user is 0 0, negation HP will be 1 1, and if it is 1 1, it will be 0 0. If it is 0 1, it will be 1 0. And then we add LB is equal to LB plus A, where A equal to 1. So why are we using this value? Why are we using A? Since LB HP is an unsigned character, if we directly give LB equal to LB plus 1, there will occur an error. So we priorly assign A equal to 1, and we substitute, and like processor substitutes A's value. So like A is also unsigned char, so it's the same data type. So the addition will be happening. And if we are directly giving here 1, we will find an error during the building of program. So LB is given as LB plus A. So for example, if the value is 1 1 and the value of A is 1, and so we are adding 1 1 plus 1, it's binary addition, so we get 0 1 0 0. So there exist and carry. If there exists and carry, CY will automatically be updated to 1. So if there is a carry in the lower byte, the higher byte also should have the change. Like for example, if the value is of HB is 0 0 and LB is 1 1 after the 1's complement, when we are adding 1, the value, the output that we are getting, which is the 2's complement, should be 0 1 0 0. So a change in the lower byte, if it goes more than 8-bit, a change should be brought in the higher byte also during 2's complement. So we are checking if CY equal to 1. This is a condition which happens immediately after LB is taken the 2's complement. And if there exists and carry, we are incrementing HB equal to HP plus 1. So there will occur 2's complement in the higher byte also. Possibility of getting a carry over there is also taken under consideration. Say for example, the value given by us is 0 0 0 0. 0 0 in higher bit and 0 0 in lower bit. So after the 1's complement, it will be 1 1 1 1. Taking the 2's complement in the LB, the value we get is 1 0 0, and we have a carry in the LB. So the HB also get incremented by 1. What HP will be like 1 0 0, and LB will be 0 0. So we have a value of 1 0 0 0 0 after the 2's complement. And since it's an 8 bit, since HB is an 8 bit and can't hold value more than 8 bit, the CY will have the value 1. This value, like whenever this condition occurs, we are incrementing a value C equal to C plus 1. So the carry we obtain will be stored in C. So how, and while displaying, we will be displaying C first, followed by HB and followed by LB, which is found in this set of statements. We display C using byte2pc first, and HB using byte2pc, and LB using byte2pc, which is a function available in the kjc serial.h. And we exit the while loop and exit the main. This program has been debugged and the hex file has been created. Let's move to the simulation part. So the setup is, we are using 8089C51 microcontroller with a virtual terminal of whose THT is connected to the RHT of microcontroller, and THT of microcontroller is connected to the RHT of virtual terminal, and the whole there's a communication between both the devices. Let's run the program. Let's go to the debug virtual terminal for the output. Okay, so sorry for that, I had to stop and run again. Okay, so let's enter the first byte as 1 0, second byte as 0 1. So the 2's complement is 0 E F F F. The 8051 returns in hexadecimal value. Let's take the case where we are using the carry flag. The second carry, we are using the condition if CY equal to 1 for the higher bit case. So the input should be 0 0 0 0. The 2's complement what we got over there was 0 1 0 0 0 0. So this is the only case where the value will be value will have a carry. In the for higher bit value will have the carry. Let's take further more executions. 0 1 1 0. So this is the 2's complement 0 F E F 0. Let's take F F F F. 2's complement is 0 0 0 0 1. So that's the program for finding the complement of a 16-bit number. Thank you.